Hi. In this video, we're going to have a look at the most recent A-Level Mechanics past paper, which is at the moment May-June 2022. The mark scheme for this paper is not available yet, so I'll just show you how I would approach this paper if I had to take the exam. But if I make any mistakes, please feel free to let me know in the comments to this video. Okay, the first question is about collision. Chances are that we'll have to use momentum. But before we do anything, let's draw a diagram to better understand what was going on before and after the collision. Okay, so we have the two spheres, A and B. A and B. The mass of the first sphere was 5 kilograms, and the second one is 3. I'm going to draw before and after. Okay, initially, sphere B was at rest, so velocity equals to 0. And the sphere A was moving towards B with the velocity of 8.5. Okay, and after the collision, velocity of the first sphere was a quarter of velocity of the second one. Before we start writing any equations, let's choose the direction of x-axis, and I'm going to choose it to the right. And now we can start writing the momentum, which is mass times the velocity. So before the collision, the sphere A had a momentum 5 times 8.5, and it's positive because the velocity of A was in the same direction as my x-axis. Momentum of the sphere B was 0. Now that must be equal to momentum of the sphere A, which is 5 times v over 4, plus 3v. Now, 5 times 8.5 is going to be 42.5. And 5 over 4 plus 3 is going to be 4.25 v. And from here, we can find v, which is 10. So my answer is going to be 10 meters per second. Okay, moving on. Question B, find the loss of kinetic energy of the system due to the collision. Right, in this question, we only have the kinetic energy, which is mv squared over 2. And we'll have to use our answer for the first question, which is v equals to 10. Okay, so the energy before the collision is going to be equal to 5, which is the mass of the first sphere, times 8.5 squared over 2. And the kinetic energy of the second sphere is 0. The energy after the collision is going to be 5 times 10 over 4. That's its sphere A, plus 3 times 10 squared over 2. That's the sphere B. Okay, let's do some calculations. The first energy is going to be 180.625. And the energy after the collision is going to be 165.625. Now we're looking for the energy loss, which is going to be energy after minus energy before the collision. And we can write down the answer straight away because 180.625 minus 165.625 is going to be 15. Joules. Question 2. Okay, so we're looking for the magnitude and the direction of the resultant force. It's a very typical question, and normally we'll have to split all the forces into x and y direction. So I'm going to draw x and y axis. It's going to be my x-axis, and that's my y-axis. Okay, let's begin. So we got a force of 20 newtons, and I'm going to start with the x-axis. Now the x component of this force is here. And if we look at the right angle triangle, then the x component is going to be adjacent to the angle of 60 degrees. So that means we'll have to use cosine. So 20 cosine 60. Let's have a look at this force, 16 newtons. It's acting in the opposite direction of the x-axis. So take it with the minus sign. And again, cosine 50. And we also have the force of 40 newtons, which is acting totally on x-axis in the opposite direction. So it's minus 14. I don't see any more forces acting on x-axis. So that means this is going to be the x component of the resultant force, which is equal to minus 14.2846. Now, let's do a very similar thing for y-axis. So we have 60 newtons acting totally on y-axis. And it's positive because it's in the same direction. Now the force of 20 newtons is acting downwards. So I'll take the minus sign. And the y component of this force is here. It's opposite of the angle of 60 degrees. So that means we'll have to use the sine. So minus 20 sine 60 degrees. And very similar to that, we have the force of 16 newtons. Again, the y component is opposite of the angle of 50 degrees. And the direction is opposite of y-axis. So that means we'll take 16 and multiply it by the sine of 50 degrees. So that's equal to 30.4228. Okay, now we'll have to calculate the magnitude of the resultant force. And to do so, let's draw a quick sketch of the resultant force. Let's say this is the origin. Our x component is negative, so that means it's acting to the left. The y component of this force is positive, so it's here. And now let's draw the resultant force. This way. Okay, now, how do we find the magnitude of this force? Well, we can just use the Pythagoras. Hypotenuse squared equals to negative 14.2846 squared plus 30.4228 squared. Then we'll have to take the square root. Okay, and I got 33.61. So that's going to be the magnitude of this force. Now, what about the direction? Again, let's use our diagram and say that this is going to be x-axis. And now I'm going to calculate the angle between the resultant force and the x-axis. So basically, that's this green angle. Okay, and to calculate this angle, I will have to add up 90 degrees and this little angle between the y-axis and the resultant force. Now, to find this little angle, we can use trigonometry. So on top, there's going to be the x component of the resultant force. And the side adjacent to this angle is going to be the y component of the resultant force. Now, what can we possibly use? We got opposite, we got adjacent, so we can use the tangent. So I would say tangent theta equals to opposite, which is 14.2846 over adjacent, which is 30.4228, approximately 0.4695. And then I will have to take the inverse tangent of that. Okay, and that equals to 25.15. So finally, the angle is going to be 90 degrees plus 25.15, which is 115.15. Okay, unfortunately, I don't have space anymore, so I'm going to state my final answer somewhere here. So the magnitude is 33.61 newtons. And the direction is going to be 115.15 degrees. It's going to be clockwise. No, sorry, it's going to be anti-clockwise. But it's that way. From the direction of x-axis. Now, whenever you have a question about the direction of the force, it's totally up to you which angle you choose unless you specify clearly that in your final answer. So for example, you could have calculated the angle between the y-axis and the resultant force, which was going to be just 25.15. In that case, you should have said 25.15 degrees anti-clockwise from the direction of y-axis. So that is also possible. Okay, time for the next question. Okay, that question seems to be about connected particles. we'll have a smooth pulley. Again, the diagram is very important. So we got 2.4 kilograms. And we also have 1.2. Okay, so question A, we have to find a tension in a string, and we have to find the magnitude of the acceleration. Again, before we do anything, we'll have to choose the direction of y-axis. I'm going to choose it upwards. And then let's draw the force diagram. So in this particle, we got 24 newtons of the weight acting downwards. On this particle, we got 12 newtons, again acting downwards. Now, both of the weights are attached to the string. So that means we have the force of the tension. And because it's the same string, obviously tension is going to be the same along the string. Okay, so that's the particle A and B. Now let's use the second Newton's law, which is the force of, the sum of all these forces equals to mass times acceleration. And we'll have to do it separately for the particle A and for the particle B. Let's start with the particle A. Now I've got the force of tension, which is acting up, and it has the same direction as y-axis, so I'll take it with the plus sign. The weight is negative because it's acting in the opposite direction of y-axis. And now it's really important to understand where acceleration is pointing. So the particle A moves down, and the particle B moves up. So that means that the acceleration of the particle A is negative because it's in the opposite direction of the y-axis. So I will take it with a negative sign. Mass is 2.4 A. And for the particle B, it's going to be positive tension, T, minus the weight, which is 12. And this time acceleration is positive because it's moving up. So it is 1.2 times acceleration. And now we got simultaneous equations. So we can subtract one from the other. And I will do term by term. Now, t minus t gives me 0, minus 24, minus 12, which makes it plus 12. So overall, we got minus 12. Equals minus 2.4 minus 1.2. That is minus 3.6 A. Now divide both sides by minus 3.6. And I got 3 1/3. I'll keep it this way for better precision. Now, we have to calculate the tension, so I'll substitute it into the first equation. So t equals to 24 minus 2.4a. So I got 24 minus 2.4 times 3 1/3. And that equals to 16. Okay, so at least we know that we got one question correctly. So we have shown that the tension is 16 newtons. And the question was to find the acceleration. 3.33 meters per second squared, correct to 3 significant figures. Okay, let's move to question B. Find the greatest height of B above the plane. Now, in order to understand this question better, again, let's draw a diagram. Now, initially, the particle B was raised 1.5 meters above the ground. And I will call this point A. So it's 1.5 meters. Okay, now what happened next? The both particles were connected. And the particle A was raised 2.1 meters above the ground. And because they were connected with a string, that means they moved together. And the particle B was raised further 2.1 meters above the ground. Now at this point, and I will call it B, the first particle reached the ground, and the second particle, particle B, continued to move upwards until it's reached the greatest height. I will call this point M for maximum height. Now, basically, all we have to know is the height BM. Now, how can we possibly calculate this height? I think the easiest way to do so is to use the energy conservation. So I will call the height BMH. And we can use mv squared over 2 equals to mgh. Where v is going to be velocity of the particle at a point B. So at this point, velocity is v, which we obviously don't know yet. Okay, now how can we possibly find velocity at the point B? We'll have to look at the part AB. Now the particle started at rest, so initial velocity was 0. We're looking for the final velocity. And we also know that the particle traveled 2.1 meters. So S equals to 2.1. And from the previous question, we also know the acceleration. So A equals to 3 1/3. Now that's a good place to use the Stewart equations. The one that looks the easiest is v squared equals to u squared plus 2as. Now let's substitute all the numbers that we know. So v squared equals to, well, u squared is 0. So plus 2 times 3 1/3 times 2.1. That equals to 14. Okay, so now I know v squared, and I can substitute it into the equation for the energy. Now in this equation, we don't even need the mass. Now let's rearrange this equation to find the height. So h equals to v squared over 2g. Now we know that v squared is 14, so it's 14 over g is 10, 20, which is 0.7. Okay, now the greatest height of B above the plane is going to be 1.5 plus 2.1, look at the diagram, plus the height, which you already know, it's 0.7. And that gives us 4.3. And I will state it as my final answer, 4.3 meters. I guess that's it for the question 3. Time to move to the question 4. Okay, you have 2 particles. I think it's, again, time for a diagram. Okay, we got a particle A, and it moves along a straight horizontal track with a constant speed of 8 meters per second. So let's draw it somewhere here. Particle A, and it's moving with 8 meters per second. And it was passing some fixed point O. Okay, cool. Now, 4 seconds later, another particle B passes O. And it has the velocity of 20 meters per second as it was passing the point O. And meanwhile, the particle A was further from the point O. Okay, and we also know that the acceleration of the particle B, A, equals to minus 2 meters per second squared, because it has a constant deceleration of 2 meters per second squared. Okay, B comes to rest when it returns to O. Find expression of terms of t in terms of t for displacement from O of each particle t seconds after B passes O. So that's very important. Now that means we start counting the time when B is at O. So time equals to 0 at this particular situation. Okay, so when particle B was at the point O, A has already moved further away, and because it's moving with the constant velocity, the distance it traveled would be 8 times 4. So speed times time, which is 32. Okay, now let's start with the expression for the displacement from O for the particle A, because that's the easiest. So when t equals to 0, A was 32 meters away from point O, so it's 32, and it keeps moving further with the velocity of 8. So it's going to be plus speed or velocity times time. So 32 plus 8t would be the formula for the displacement of the particle A. Now, for the particle B, we'll have to use Stewart equations. And the one that I'm going to use is going to be S equals to ut plus 8t squared over 2. So the displacement of B is going to be initial velocity, which is 20, times t minus 2t squared over 2. Let's simplify that. And we've got 20t minus t squared. So that's pretty much it, and we're ready to state the answer. Displacement of A is going to be 32 plus 8t, and displacement of B would be 20t minus t squared. Okay, that's it. Moving on to question B. Find the values of t when the particles are the same distance from O. So that means displacement of A equals to displacement of B. Now, since we know the expressions for the displacement, all we have to do is to say that 32 plus 8t equals to 20t minus t squared. Now it's just a simple quadratic equation. Which I hope we can solve very easily. I'm going to use the quadratic formula, although I feel like I could have factorized actually, but okay. Okay, 12 plus or minus 4 over 2. And if I take it with a positive sign, I got 8. And negative would be 4. Okay, good. So the question was to find the values. That means we'll have 2 of them. 4 and 8 seconds. Next question. Okay, we'll have to draw the sketch. I'm going to write down somewhere our expressions for the displacement. Now, A is going to be 32 plus 8t, and B is going to be 20 minus t squared. Sorry, it's 20t. Let's start with the particle A. That's going to be a straight line. It starts with 32 meters. And let's calculate the displacement when t equals to 20. It's 32 plus 8 times 20. Which is going to be 32 plus 116. 192, almost 200. Okay, so the straight line from 32 almost to 200, something like that. Now, for the particle B, it's going to be quadratics. Now we can see that when t equals to t equals to 0, displacement equals to 0. Now we also know from the previous question that both particles have the same displacement when t equals to 4 and when t equals to 8. So our quadratic function is going to intersect the straight line at these 2 points. Okay, now let's calculate the displacement of B when t equals to 20. 20 times 20 minus 20 squared, which makes it 0. And just in case, let's find the vertex of these quadratics. We don't have to make any further calculations because we know that the quadratics opens down and it intersects, well, in this case, t-axis at the point 0 and 20. So that means the vertex is going to be in between, which is 10. Okay, and I will have to try to draw it the best I can. Okay, something similar to this. Let's move on to the next question. Right, this time it's about the inclined plane. It is in equilibrium and the block is about to move up. Now, this fact is going to be helpful in order to determine the direction of the force of friction. So we know that the force of friction is always trying to oppose the motion. If the block is about to move up, that means the force of friction is going to move to act down, and I will indicate it straight away so I don't forget in the future. Now, as always in these questions, let's draw the complete force diagram. We had the weight of the block, and it has a mass of 12. So the weight is going to be 120. We also have the normal reaction, which is perpendicular to the surface. And I don't see any other forces acting on this object. Also, let's choose X and Y axis. It's always a good idea to choose X axis along the plane, and Y axis is going to be perpendicular to this plane. Now, this little angle between the weight and y-axis is always the same as the angle of the inclination of the plane, which is 24. Okay, and now we're ready to start writing the equations. It's, of course, going to be the second Newton's law. The sum of forces equals to mass times acceleration, and it's going to be written in both x and y axes separately. Starting with the x-axis, we've got 65 newtons. And the x component of this force is adjacent to the angle of 36 degrees. So that means I will have to use cosine of that angle. So got 65 cosine 36. Now we also have a force of friction, and it's acting in the opposite direction of the x-axis. So I'll take it with the negative sign, so minus force of friction. And we also have the x component of the weight, which is right here. It's opposite of the angle 24 degrees, so I will take it with sine. So minus 120 sine 24. I don't see any other forces acting on x-axis. So that should be equal to mass times acceleration. And because our system is in equilibrium, that equals to 0. Because A equals to 0. Now on y-axis, we've got the normal reaction, n, again positive because it has the same direction as y-axis. We also have the y component of this 65 newtons force, which is here, and it's opposite of the angle of 36 degrees. So plus 65 sine 36. And the y component of the weight is acting downwards. So I'll take it with a minus sign. That's 120. And it's adjacent to the angle of 24. So it's cosine 24. Again, there is no acceleration on y-axis. So that means the sum of all forces equals to 0. Now we also know that the force of friction equals to the coefficient of friction, which is mu, times the normal reaction n. Now this time we've got simultaneous equations, and hopefully we can solve it for mu. First things first, I will find the normal reaction from this equation on y-axis. N equals 120 cosine 24 minus 65 sine 36. Now I have to calculate that. Okay, so that equals to 71.419. Now I can substitute this into the force of friction. So the force of friction equals to 71.419 times mu. And this goes into the first equation. (65 cosine 36) minus 71.419 mu minus 120 sine 24 equals to 0. And from here we can find mu. So mu equals 65 cosine 36 minus 120 sine 24 over 71.419. Again, some serious calculations going on. Give me a couple of moments. Okay, got 0.05289. I will state it to 3 significant figures. 529. Next question. Okay, so question A seems to be about energy, work, and power. Now, at this point, it shouldn't be surprising that I'm going to start with the diagram. So that's going to be the car. Okay, so we know the angle. We could say that sine theta is 0.12. Initial speed of the car is 11. Now we know that the time is 12 seconds. And the car has traveled 150 meters up the hill. And it has reached the velocity of 16 meters per second. We also know that the engine is working at the constant rate of 24 kilowatts. So it means the power was 24,000 watts. And we have to find the work done against resistive forces during the 12 seconds. Okay, since the engine is working, we'll have to find out what happens to the work produced by the engine. Okay, so what happens is that the kinetic energy and the potential energy of the car both are increasing. So the work of the engine is going to be equal to the increase of the energy and it also goes to do some work against the resistance. So work against resistance. Okay, but first of all, what's going to be the work done by the engine? We'll have to remember the definition of the power. Power equals work done over the time taken. So to find the work done by the engine, we'll have to multiply power by the time. So it's 24,000 times 12. Times 12. Okay, so that is going to be equal to 288,000. Now, what about the energy? Let's split the motion into, let's say, two parts. So first is point A at the bottom of the hill and the point B here. Now, at the point A, we only have the kinetic energy, which is mu squared over 2. The mass is 900 times 11 squared over 2. I will keep it for later. And at the point B, we have both kinetic and potential energy. Now, kinetic energy is going to be mv squared over 2, which is 900, times 16 squared divided by 2. And the potential energy is going to be equal to mgh, which is 900, one more 0, because I'm multiplying by 10, and I will have to find the height. Now, how do I actually find the height? Using trigonometry. We've got the right angle triangle here. We're looking for the opposite side, and we know the hypotenuse. So that means we can use the sine ratio. So sine theta equals to opposite h over the hypotenuse, 150. And to find the height, I will have to multiply 150 by sine theta. So it's 150 times 0.12. 18. Okay, now we're ready to substitute everything into this equation and find the work done against the resistance. Now, the work done by the engine is 288,000 equals to increase of the energy. That's going to be energy at the point B, 900 times 16 squared over 2, plus 9,000 times 18 minus energy at A, 900 times 11 squared over 2, plus the work done against the resistance. Now we can rearrange this equation for the work done against the resistance, and we will get 65,250 joules. And that's going to be my answer for this question. Let's move on to question B. Okay, this time we have a straight horizontal road. That's the car. We've got the resistance to the motion. And the car travels at a constant speed. So that means we have the driving force. And this time the power of the engine is 32 kilowatts or 32,000 watts. Okay, we're looking for the speed of the car. So first of all, because the car travels at a constant speed, that means there is no acceleration, A equals to 0. So it means the sum of all the forces acting on the car is 0. So the driving force minus the force of the resistance equals to 0. Now that means the driving force equals to 1520 plus 4V. Now, what would be the connection between the power of the engine and the driving force? Of course, as everybody knows, the power equals to the driving force times the velocity. Okay, so that means the driving force equals to the power over velocity, which is 32,000 over V. Now, from these two, we can make one equation and solve it for V. Okay, now let's multiply by V and we'll get 1520 V plus 4V squared equals to 32,000. Now let's divide it by 4 to make things a little bit easier. 380 V plus V squared equals to 8,000. Now that's just a simple quadratics. Okay, let's use the formula. Minus 320 plus or minus square root of 144,400 plus 32,000 over 2. And that equals to minus 3. Oh, that's supposed to be 380. My bad, not 320. Uh, 420 over 2. Now, I'm going to take only plus in this formula because velocity should be positive. That gave me 20. Okay, so that's my final answer, 20 meters per second. Let's move on to the next question. Okay, now we have the formula for the velocity, and we'll have to take the we'll have to show that there is an instantaneous change in the acceleration at t equals to 10. Now, how do we find acceleration from the velocity? We'll have to take the derivative with respect to time. So the first formula will give me a equals to 0.5 when t is from 0 to 10. Now, if I take the derivative of the second one, I will get 0.5t minus 8 if t is from 10 to 20. Now, if t equals to 10, obviously the first acceleration is going to be 0.5, it's constant. And now let's substitute t equals to 10 into the second equation. You'll get 5 minus 8, which is minus 3. Okay, so when t equals to 10, the first formula gives us a acceleration equals to 0.5, and the second one gives us negative 3. Well, obviously it's not the same number, therefore there is instantaneous change in acceleration. Okay, let's move on to the last question. Find the total distance covered from 0 to 20. To understand better what's going on, I'm going to draw the sketch of velocity time graph. Velocity and time is going to be here. We start from the first formula, from the first equation, from 0 to 10. And I'm going to keep it somewhere on the left for future reference. It's 0.5 t. And the second equation is 0.25 t squared minus 8t plus 60. Now, the first one is going to be a straight line. It starts from 0, 0. And when t equals to 10, let's substitute it. And it's going to be 5. So I can draw it straight away. Now, the second one is going to be quadratics. Okay, so first of all, let's verify if t equals to 10 gives us velocity of 5. It should. Zero 0.25 times 10 squared minus 80 plus 60. Okay, and indeed, that is 5. Okay, so now we can draw our quadratic function, but the only problem, we don't really know where it's going to intersect the t-axis. Let's find it out. We're going to intersect the t-axis when v equals to 0. So we'll have to solve the quadratic equation. Now 64 minus 40c is going to be 60 over 2 times 0.25, which is 8 plus or minus 2 over 0.5. So t is either 20 or 12. So somewhere here, we're going to hit t-axis, velocity is 0, and we also intersect here when t equals to 20. And in the middle, we're going to have the vertex. Now this. Okay, now how do we calculate the total distance traveled by the particle? Well, from the velocity time graph, it's going to be the area under the graph. And I will split it into 2 parts. I will call it A1. This one is going to be A2 and A3. Now, A1 is going to be just the area of the triangle. I will just calculate it straight away. Base times height over 2. That gave me 25. Now, for the area 2 and area 3, I'll have to integrate. And the reason why we need a sketch and the reason why we have to calculate where we intersect with t-axis is that the integral from 12 to 20 is going to be negative. That means the displacement of this particle is going to be negative. However, the distance is going to be positive. So that means we'll have to calculate the integral separately. So the integral from 10 to 12 is going to be positive. From 12 to 20 is going to be negative. But when I calculate the total distance, I will take it with the plus sign. So A2 is going to be the integral from 10 to 12 of 0.25 t squared minus 8t plus 60 dt 0.5 t cubed over 3 minus 8t squared over 2 plus 60t. And the limits are from 10 to 12. Now let's substitute the upper limit. And take away, I'm going to substitute the lower limit. I got 4 2/3. Now the very last integral, again, is going to be from 12 to 16. Oh, sorry, from 12 to 20. It's the same function. And obviously it's going to be the same integral. I'm going to substitute the upper limit, 666 2/3 minus 1,600 plus 1,200 minus, and we've actually already calculated the lower limit when t equals to 12. So I'm just going to copy it. That gives me minus 21 1/3. So as expected, it is negative, but when I calculate the total distance, I'll do here on the right side, I will take everything with the positive sign. (25 plus 4 2/3 plus 21 1/3. That is 51. Okay, and this is my final answer for the final question of this paper. I hope that was useful, and I hope I didn't make lots of mistakes. But if I did, please do let me know in the comments. And with that being said, bye.